The goal of this project was to build a solar tracker that is purely mechanical, which is, in this case, driven by gravity. The main focus for our engineering team was to design the water tank that actuates the rotation of the solar panels. We also designed the spring-driven return mechanism for the solar tracker. This project will be an innovative, economical solution for a normal household to incorporate clean energy into their everyday life.
To do this, we designed a spring system that hooked to two tanks, the water tank and the siphon tank. The idea was that at the beginning of the day, the sprinkler system would turn on and fill the water tank, and the spring system would lower the two tanks down. Over the course of the day, the drip emitter would drains water from the upper water tank into the siphon tank. These components were the focus of our project.
The design for our water tank allows 6 gallons of water to be held in it. And so our drip emitter drips about 1/2 gallon of water into our siphon tank every hour. And then we built our siphon at the specific height so that when 1/2 gallon of water is dripped into it, it will create the siphoning effect and release that amount of water from the system. And so because we have 6 gallons of water starting in our system and to begin with, and then 1/2 gallon of water every hour is being dripped into our siphon tank using the drip emitters, and then our siphon is releasing that 1/2 gallon from our system every hour, our solar tracker will run for approximately 12 hours throughout the day. Another component of our design is our lower plate. The lower plate goes between our water tank and our siphon tank. The lower plate has a couple different purposes. One purpose is it is an attachment point for our springs. In addition, it also serves as a support for our water tank. Our water tank has 6 gallons in it, so we need to ensure that we're supporting all of that weight through a flat, balanced surface. And lastly, our lower plate serves as an integration point for our system to integrate with our client's components. The sudden release of water from our siphon integrates well with the components that we are receiving from our client. And the components that we're receiving from our client are the things that are actually tracking the sun, and they integrate in our design as our system moves up and down a central pole. The central pole is a square pole, and in our design for our lower plate, we have a square cutout so that our system slides up and down that central pole nicely without twisting and turning. Also attached to that lower plate are rollers. So the way that the solar tracker actually tracks the sun is through cam tracks. And the cam tracks are created using an equation to perfectly track the sun over the course of the day. And so these rollers attached to the spring plate are rolling up and down these cam tracks so that as our system is moving up throughout the course of the day using the springs, the rollers are actually twisting the cam tracks as it moves up and down the central pole. And then these cam tracks are attached to bearing plates. And these bearing plates are what allows these spindle arms to rotate throughout the course of the day, and the solar panels are therefore then attached to the spindle arms, so then as our system moves up the central pole over the course of the day, through our spring system, the cam tracks are rotating as well as the spindle arms, which in turn rotates our solar panels to track the sun over the course of the day.